Hello everyone, welcome to our channel. So here we have come up with the new questions asked in this GATE exam. So this question here related to our frequency response, and they given actually body plot, and they only given the magnitude plot. They haven't given the upper phase plot because whatever question they want, this is only needed for magnitude plot actually. So here they given the magnitude plot, and they asking they given actually two statement, and out of them which statement is correct and which statement is false, we need to tell with this using this magnitude plot. All right. So here the first statement they stated here, the transfer function has three poles and one zero. We need to tell how many number of poles and zeros from this bode plot, I mean magnitude plot. And statement 2, at a very high frequency, it means uh, when omega means frequency approaches to infinity, what the phase contribution by the system, and system magnitude plot they given actually here. So for this type of questions, like, and out of this statement, which statement is true and which statement is false. So like that we need to solve these questions. And for this, what's the essential details to be required? What is the useful data to be required to solve the questions? So here, one more thing actually here, like poles, as we know, poles and zero we know, like transfer function, like this here ts is a numerator ns by denominator. Yeah, we can say this is a ratio of the output, Laplace transform of output by Laplace transform of the input, provided all initial conditions should be 0. Okay, then it's called the transfer function. So as we know, this is a one, it consists of the numerator polynomial, okay, and denominator polynomial, and the roots of numerator polynomial is called the 0, and roots of denominator polynomial is called the poles. Okay, and what's the useful data for the solve the questions? As we know, asymptotic bode magnitude plot shows the magnitude response of system at a different frequency. Okay, once the frequency we are varying, okay, frequency we are varying, and we have to find out the, we have to take the magnitude and plot the graph. And here we are unit is decibels. This in dB. Okay, will explain. And second, the given bode plot, bode magnitude plot can be used to identify the system. Like in practical application, bode plot is very helpful to find identify the system. I means like we need to find out the poles, zeros, and DC gain. Okay, and third is phase contribution of pole at infinite frequency is minus pi by 2. Okay, so poles contribution at infinity, like 1 by s, this is pole. Okay, so as you know, this is a 1 by j omega, so minus pi by 2. If you put the infinity omega like 10 inverse omega by, okay na, this is minus pi by 2, and 0 is giving the plus pi by 2 at infinity. Okay, once omega tends to approach the omega tends to infinity, so zeros give the contribute the pi by 2 phase, means 90 degree, and poles give the minus pi by 2. Okay, and one more thing, in case of bode plot, as we know, poles lie in the denominator. It means it is a roots of denominator polynomial. Okay, so the gain decreases as the frequency increases in case of pole. Okay, so pole is responsible to decrease the gain. Okay, once increases the frequency. If you more specifically, the gain decreases with a factor of 10 for every 10-fold in frequency. What does that mean actually? Like this is my like this is point, for example this is a 2. Okay, gain is 2, and he is saying in each, like this is a point, for example this a point is 10. Okay, for this gain is 2, and if you go for a 10-fold means 100, means 1 decade, then gain is 0.2. Okay, so gain decrease is 0.2. Okay, so what is the slope for this? If you find out, as we know in bode plot, this omega is a log omega axis, and this is a 20 log magnitude, right? So if you find out the slope for this, we can apply this formula. Slope is equal to y2 minus y1 by x2 minus x1. So here final value log, final value 0.2, right? So we can say 20 log I am just defining in the definition whether it is coming this slope or not. So 0.2 minus 20 log 2. Okay, divide by log 100 minus log 10. Okay na? Okay, let me change the color. So 20 log 0.2, base is 10. Okay, understood. And I am just taking a 20 common, right? And log 100 is 2 minus log 10 is 1. Okay na? Because here base is 10, 100 we can say like that. So it is coming out log 10 to the base 10 is coming out 2. All right. So 20, this value how much coming? Give, let me calculate this. So log 0.2. So this is coming minus 6989. Okay, and then log 2, then log 2, then log 2 is coming 0.3010 divided by 1. So this approximately coming minus 1 by 1. So it will be giving the minus 20 dB per decade slope. I am calculating the slope, right? So here you can understand that pole gives the minus 20 dB per decade contribution in slope. It means system gain will be decreased by the pole and with the slope of minus 20 dB per decade, and 0 it increases system gain. Same slope is same, but here nature will be increasing rather than decreasing. Here nature will be increasing like that 20 dB per slope. So here you can see in our graph, in our magnitude plot, like initial nature, this one, uh, like they given minus 20 dB per decade. So you should understand that this is a caused by the pole. Okay, and initial this slope given by the how many number of poles and zero at the origin. So since this is minus 20 dB per decade, only one pole, so one pole at the origin, and gain also there, but if you extend this line, some gain always there, but it is not required for this question, so it will be k by s. All right, and let me change the color. Then we proceed this graph, and this one point you can see this is one radian per second. This point you can see slope again going to change minus 20, and here after this minus 40. So minus 20 get added. So it means we added one more pole here. Okay. So this pole like that 1 by s. I am writing in the time constant transfer function. Time constant like format in transfer function. Okay. Like s1 t1 plus 1. 1 by s t1 plus 1, where t1 is a 1 by omega 1. Omega 1 is equal to 1 radian per second from this question. Okay na? Alright. And then after this till to this we need to see the corner point, a corner frequency from which at which our slope going to change. Okay, till here till 20 slope again going to change. This is minus 60 again going to system again going to roll off drastically till initial is minus 20, then in between minus 40 degree per decade, and after this minus 60 degree. Okay, so this will be again one more pole. So pole 3, pole 2, pole 1, one pole at origin. Okay, so initial nature, just keep your mind, like in a bode plot, like initial it can be initiate like that, either this plus 20 dB per decade, minus 20 per decade, and this multiple also like 40 minus 40. So like that repetitive pole and zeros can also exist at the origin. Okay, so one more pole here, we can say 1 by s t2 plus 1. So we get the where t2 is equal to 1 by omega 2. Okay, there is no numerical this question not related to numerical value actually. This only like logic we need to tell this question actually. Okay, we need to solve the questions. So here we just need to combine this all term. So k by s into 1 by s t1 plus 1 and s t2. Okay, t2 plus 1. Okay na, and then so you can see straight away statement 1 they given the 3 poles 1 0. There no 0 at all, only 3 poles there. Okay, so first statement is wrong. Okay, it's false. And they asking a very, if you can see what is the phase contribution for this system. So for this we need to convert in j omega. So j omega like how much there, you know, k by s give the contribution minus 90 already. Okay na, minus j by s and minus 10 inverse, and this is t omega j omega, so we can say omega 1 omega t1, sorry, omega t1 minus 10 inverse omega t2. Okay, just I am substituting as j omega. Okay, hope you understood. So here, if you approach the omega to tends to infinity, 10 inverse infinity is minus 90. So minus 90, minus 90, minus 90. Okay, plus 9. Okay, so you will get the minus 270 degree or minus 3 pi by 2 radian. Alright, so here contribution is minus 3 pi by 2. Okay, so which B option is correct. Okay, na? So this question is solved. If you extend this question, like if you find out the like here, uh, yeah, here K means gain cannot be found out because they haven't defined the. Um, no, we can find out if you find out this here. Okay, all right. So here one more thing actually we can solve it. Like as we know, ky transfer function we know na, ky as t1 plus 1 as t2 plus 2. Okay, and then here you can see as t1 plus 1 and as t2 plus 2 plus 1 t2 plus 1. So here if you find out the like we want to what is the steady state error for this. Okay, so like be given the input for be given the step response input, for example. Okay, step response. So what is the kp value? Kp constant limit s tend to 0 gs. Okay, so gs they given. So we get the ky s t1 plus 1 s t2 plus 1 and they given s here. Okay, so what is the value actually? This value is coming infinity. So kp value infinity, then what is the procedure for this? 1 by 1 plus kp. So it should be 0. So for unit step response for this system has the history error is 0. Okay, like if you change the input like ramp input like that, right? So we can say RT is equal to TUT. Okay, let me change the color. So this my T, this my RT we can say. Okay, so for this what is the velocity error constant? Limit s tend to 0 as gs. All right, so as gs. So here you can see k by s plus t1. So a has cancelled out. It means you will get the constant k value, right? K value. So what is error? Error for this is finite, 1 by k. So here you can see if you increase the k value, gain DC gain value, error will be reduced. So for ramp input, this system has shows the finite error. All right, and then final, if you go for a parabolic input, we can say acceleration constant. Okay, parabolic means like we giving the input is t square by 2 ut. like that. So for this, what is the acceleration constant? This is standard. K is equal to s equal to 0 a square gs. So limit s tend to 0. So gs value is k by as t21 t1. So here as cancel out, but as still remain in numerator, so value is coming 0. So k 0, then what is still for this is infinite. Okay, so here you can see this initial nature of the body plot. Okay, minus 20 dB per decade. This is very important to tell that whether system for various kind of input, whether it has the error, is error or not. So here we have seen for step response error is 0, and for ramp input error is finite, and for the parabolic input error is uh, parabolic input error is infinite. Okay, so like that we can get the details and get the more ideas about the how system would behave. Okay, so for this we have understood. So our the question they asked is very simple question, but we can extend, we can think about this question. Okay, so that we will not explain much, otherwise video will go long actually. But we will explain slowly the and upcoming videos, so that we can cover all concept which only frequently asked in the gate exam. Okay, so all right, so that's all in this video. Thanks all.